Okay, the next solid we're going to be using to find volume is a prism. And so a prism is a geometric solid made up of bases, and those bases are congruent parallel polygons. And then the things that connect the bases to each other are called lateral faces. So just to review again what volume means, volume is how much it takes to fill the entire space. So to fill the entire thing inside. All right, so just to show you on this diagram what this definition means, the bases here are the squares on the bottom and on the top. So I can see that these are squares because of these congruent tick marks. And then I've got a measurement here of 6, which means the measurement of all of the sides of the base are 6. So this is a square. So the shape of the base here is a square. Okay, so we've got a square on the bottom for my base, and then I've got one on the top. Those are the parallel pieces that are mentioned here in the description of a prism. And then what separates those bases is the height of the prism. So the height of the prism here is 8 meters. We need the area of the base. So what we did in our previous notes is we talked about the area of squares. So the area of this square base that I've highlighted in yellow, so that area is to take the side and square it. So that side has a measurement of 6. So 6 times 6 is 36. So 36 meters squared is the area of this square base. What we're going to do for the volume here of a prism is we're going to take the area of that base and then we're going to multiply it by the height, so how it stacks up here vertically. All right, so that's what this formula is saying up here. Volume is the area of the base, so that's the area of that square base, times the height of the whole prism. So volume is area of the base times the height. So your area of your base was 36. The height is 8. So that's 288 meters cubed. Again, we use the units cubed on volume. So you were previously working with area, so your units were squared. We're back to volume again now, so you're making it cubed. You may have seen this formula before for a volume of a cube. So this might look familiar. Length times width times height. So length times width times height would mean that your length here is 6, your width is 6, and your height is 8. So you could also do 6 times 6 times 8 and get the exact same answer of 288 meters cubed. You have to be careful if you're going to use this method because it'll only work if your base is a rectangle or a square. So when we get down to number 4, we're not going to be able to do it that way. I'm going to continue with this formula, but at the end of each problem, I will show you the area, the volume. Change this. The volume, which is length times width. Okay. All right, moving on to number 2. So number 2, we're going to select the base. I'm just going to pick the bottom right here. It's a rectangle. And then I've got another rectangle here on the top. Those are my parallel bases. So the shape of my base, that is a rectangle. I know that because these measurements are not the same. So my base is a rectangle. What we learned in previous notes is that the area of a rectangle is the length times the width. So that's 3 times 7. So the area of this base is 21 feet cubed. And then our height is what is separating the bases. So that's right here. That's our height. that's 5 feet. So our volume formula is the area of the base times the height. So the area of my base is 21 times my height of 5 gives me a volume of 105 feet cubed. If you wanted to use what we had written above, the volume is length times width times height. Again, you've got 3 times 7 times the height of 5. And you'll get that same answer of 105 feet cubed. Okay, moving on to number 3. For number 3, I'm going to put the base as this bottom rectangle. And then there's the parallel base on the top, rectangle with the same dimensions. So the shape of the base is a rectangle. The area of a rectangle is length times width. So that's 10 times 4, which is going to be 40 meters cubed. And then the height is what is separating those bases. So the height is not a part of either base, and that is 6 meters. So our volume is the area of the base times the height. So the area of that rectangle, which is 40, times the height of the prism, which is 6. So 40 times 6 is 240 meters cubed. So let's highlight these 3 answers that we have found. Oops, number 2 and number 1. All right, so that's the goal, is to find the volume of each of these prisms. So we can do our shortcut way on number 3 as well, because number 3 has a base that is a rectangle. So we can do volume is length times width times height as well. So 10 times 4 times 6, and we get the same answer, 240 meters cubed. All right, so that little shortcut, or that formula that you probably saw before in middle school, that can be used on examples 1, 2, and 3 because the shape of the base is a rectangle or a square. But that's not going to be able to be used on example number 4 because the shape of your base is different. So remember that the base has to be 2 pieces that are parallel. So just like on the cylinders, you had circles on the top and the bottom, or a circle on the left and the right. You have to have those pieces that are matching in order for them to be the parallel bases. So in this example, number 4, we've got a triangle here in the front, and then the matching piece, that parallel polygon, is in the back, and it's a triangle. So this is different than the first 3 examples. So the shape of the base here is a triangle. And when we reviewed the area of a triangle in our previous notes, that was base times height divided by 2. So in this triangle, we have 8 times 5, so base times height, and we are dividing by 2. So the area of the highlighted triangle is 20 feet squared. And then the height of the prism is going to be what separates those 2 triangles. It's what connects them. Right? So this height is 10. So our volume of this prism, you take the area of the base and you multiply by the height. So the area of this triangular base is 20 times the height that separates the bases, or connects the bases, I should say, which is 10. 20 times 10 is 200 feet cubed. Okay, so that's finding the volume of each of the prisms that we had as examples in 1, 2, 3, and 4. The thing that I haven't talked about is what you name them. Okay, so you can call them a prism, but a more specific name is to name them with the kind of base that they have. So in number 4, since that base is a triangle, we call this a triangular prism. If we move up to number 3, I see a little error on number 3 that I want to correct. The area of that rectangular base should have a square on it. Just be careful that you don't do that too. So example number 3 has a rectangle base, so we call that a rectangular prism. Same thing on number 2, the base is a rectangle. And I can see I made that mistake here with the area as well because I'm going too fast. So we need to change that to a square. Okay, this is a rectangular prism. And then the last one, number 1, the shape of your base is a square, so we call this a square prism. So we don't have to add the extra words on here like we did with rectangular or triangular. It's just a square prism. Okay, so you've got your practice on volume of prisms to work on for homework tonight. If you got any questions, reach out to me. Hope you guys are doing well.